Hello, in today's video I will show you how to wire a socket and a plug using a simple double wire cable. Of course, since we are on the European market, we also have protections, but we are not going to use the earthing connector because this is more like a test system, so we are not really going to be entirely up to the safety level that you may be wanting, but however I hope you will find this video useful. This procedure that I'm going to show to you is not overly complex. In fact, it's very simple. It should take just a couple of minutes. I'll mention some things along the way so that it's not going to be an empty presentation. So without further ado, some of you may wonder why we will use such an old and actually horrible looking scissor, but there is a reason for this. I want to show you a technique that was used many decades ago, particularly when people didn't have proper wire strippers, and to prove to you that it's still viable to use such a method even 30 years after it was more than obsolete, at least for hobby purposes. So let's start off. First of all, we have the cable and we have to strip the external insulation. So we are going to make just a small cut over here. We are attempting to make it relatively uniform. So you see me going round and round the cable. There is not very much force being applied on the scissor. Actually, it's quite low because I want just to strip it. And if the dent is enough, it should be possible to lift it. This process may take some attempts, but I want to show to you exactly how. So first of all, don't over tight the scissor, just tight it enough so that it protrudes to through the external PVC sheeting. And then you should at one point be able to push it quite seriously. Of course, it doesn't always succeed. Let's take another attempt. Okay, good. So right now we should be able to continue this using our fingers and particularly our nails in order to strip the wire. As you can see, it was quite unacceptable stripping. Even if it seems a bit odd over here, I think it's okay. If you want, and for better safety, we can make another attempt, because this is always instructional or useful to know. So we are going to make another attempt, and this time we are going to make less of a dent in the cable so that when it separates it's not going to be that violent. I'm going to see if this is going to succeed. Over here we made a small protrusion, so probably we are quite close to the sheeting being completely broken. So let's try and make it lift again. Okay, we had some partial success, but it wasn't quite possible to lift it entirely, so I'm going to do it a bit longer, and of course I'm going to attempt to apply the same technique. Actually, there are more ways of doing it, and this particular scissor is a very bad example because partially it's not as good of it doesn't have quite a good cutting surface. It's actually very old and it's partially blunt, so you have to accept the fact that with a smaller scissor and probably with better handling it could have been much better. Okay, I think we have a bit of success over here. So let's make an attempt by just pulling this and inserting our nails. And full success. I think that it's quite reasonable. Alright, so because this part has longer wires, we are probably going to use it over here, since I'm expecting the distance to be an advantage. On the actual plug, I think it's good as well if you're going to strip it around here, so that's not a problem. Anyway, let's go and strip the other part at a different distance, and we are going to see which one is the better approach for a particular end. Okay, so we're making some indents in the PVC coating, and I think this should be plenty enough. This technique is actually horrible for a couple of reasons, but I'm just going to show to you what you can do with mostly hobby equipment. This is actually very important if you are just starting to have an inclination, a hobby towards electrical stuff. You're going to learn a lot by trying to unstrip the cables, and as you're going to have more years of experience, you're going to find the best ways to do it. But particularly when you're starting this and you are probably a teenager, I think that such a technique is actually very good, because it goes on to show that you really don't need expensive equipment to achieve that. Okay, I think this was almost a perfect success with no visible protrusions on the insulation for these two wires. So I think this was entirely a success. Alright, so let's see. We are going to use the classic Phillips head screwdriver. Of course, I could have gone even more old school and show you that you don't need this kind of crosshead screwdriver, and you can use a simple one. As you can see, this particular screw also has plenty of space to use a standard screwdriver, but in general with a Phillips head screwdriver you have a much better chance of centering on the screw, and I still think that this one has the best chance of success. And actually, since Phillips head screwdrivers are very common, it's very difficult not to find one today compared with 30 years ago when this was actually a challenge. And since you need this kind of Phillips head screwdrivers for so many situations, I think that you are not going to be disappointed. Okay, it seems that this part doesn't easily separate from the other. I'm not entirely sure why this is the case. There might be another screw, or there might be some clips over here that are making it even more difficult. I'm not entirely sure. But here I don't sense a hidden screw. Alright, so probably I'm still thinking that there is something that holds it over here. There may be two additional screws, but I'm not entirely sure where they could be. Okay, let's see if this part separates easily from the other. And if not, I will have to assume that this part should be separated by other means. It's quite forceful, I have to say, which is a bit of a surprise. But I'm still expecting something not to be quite... Alright, so yes. Expecting some sort of... Okay, let's see. This is actually a wall mount socket. We are using it mostly because it's a low profile socket. It offers enough durability to be a bench socket. So this is why I'm using it. Ultimately, it's not particularly the best way to have a socket in such a small installation. Okay, so Yes, these are coverings so that we could place an insulated tube, and the cable passes inside it so that the connection can be somewhat waterproof for outdoor applications. In this case we are not going to use it, but I'm pretty curious if there is something beneath this side, some sort of hidden screw that may be the key to be able to let's say unmount this or tear apart this socket. I'm not entirely sure how it should be, and of course there are no instructions, so we have to rely on intuition. Right now I don't think I can go any further, so I will try and see how the socket can be left temporarily aside, and we are going to focus on the plug. There are many plugs. This is not a particularly good model. I chose it only because it's easy to distinguish which one you are plugging in a multiple socket array, and in this case I don't mind if it's black and the cable is white, but for aesthetic purposes, yes, the cable should be white and the plug should be white as well. Alright, if we are looking over here, we are finding the standard European plug that of course doesn't have earthing. It should be a different kind of plug to have earthing. Yes, what I can say about this plug, I think it's quite fine, although you have clearly noticed one major issue with it. It's not particularly well built, it's not bad in itself. I think that the cable retention should be able to hold this one quite well. It's actually, I think, 2 by 0.75 cable. It should be the cross section of the conductor. It's not 1 millimeter as far as I can tell. Although it could be, I'm not entirely sure. I have not seen these cables for a long time. It should be printed on the cable. Let's see if I can find it. If I can find any sort of mention. Yeah, two wires, 0.75 cross section. Let's see if I can show to you. These actually are clues that are very important when you're making any sort of repair. Sorry, it wasn't a good. I don't know if it's possible to see it. I think right now you have a reasonable chance. It's somewhere over here. Let's see if I can make it slightly better. Unfortunately, we don't have much success. Okay, that's it. If you look closely over here, you're going to notice that it says 2 multiplied by 0.75. So that's the cross section of the cable. Okay, so it's two copper conductors that have this surface area. I think that this cable is quite enough for 10 amps. I'm not expecting it to have such an issue. In general, it could work with smaller currents perfectly. That's not the issue. And with higher ones, of course, we are pushing it by. But we are not using this bench socket for anything that is remotely high power. So since we are focusing probably on devices that are going to draw at most 100 to 200 watts, 500 watts tops, I think that it's safe. Alright, so let's go on and show you how we do it, how we strip the insulation for this small cable. Since we are not having an elliptical covering, I think this one is going to be very easy, because you just have to go round the cable, and then yeah, as soon as you are going to pinch it, just push it and that's it. Yes, as you can see, quite clearly done. Of course, when you're going to use a scissor, you want to be very careful and not pinch the cable, because as some of the copper inserts are going to get loose, the more you're going to stress the connection and the less reliable it's going to be over time. So you have to pay attention to this and try to reduce as much as possible the stress on the actual conductor, and focus most of the energy just on slowly and thoroughly removing the outer insulation layer. So we are going round and round. I think that right now we quite pinch the cable, so we just have to use our nails and push it, and it was quite easy. Of course, after you're going to uncover the actual copper, it's better to twist it so that when the screw is going to be applied on the cable, it's going to avoid making each and every particular wire loose. So it's better to do it that way. Some electricians are not going to agree that is still necessary, but for wire crimping solutions that still rely on the screw connector, I think it's well suited. Alright, so let's place the first one and notice if we have enough space available, because if not, we will have to relieve the wires a bit so that there is more room and the cables are less forced to reach such a position. I still think that the way in which it's screwed is not particularly optimal. I think that the best way would have been to have screws on this side, so that when the cable is going to be crimped, is not the wires would not have to be at a 90-degree angle. With this particular plug, you are having no other choice than having it in this way. On the other side, the screws are quite massive, so I think they will be able to put proper pressure on the wires, but still the fact that they are going to be at 90 degrees, I think it's already an issue. Possibly this may be one of the reasons for which the manufacturer didn't specify more than 10 amps, which is not particularly large. Even if the construction itself may not be bad, I still think that the way in which the cables are being placed is not particularly ideal, so the design is a bit flawed. But anyway, let's see. Yes, I still think they are going to be a bit forced, so we are going to use another technique you're going to notice very soon. We are just going to pull a bit the wire so that they are going to be a bit more exposed. Although we could use the scissor again and strip part of the external insulation, I still think that this one is a better approach if done carefully. However, as a strain release, we could make a minor cut over here so that there is going to be less pressure applied on the cable itself. And in this case, we are just going to pinch it like that on one side using the sharpest tip, and this will ensure that we have very low stress in this area. And this will help the cable survive better rough handling. Alright, so right now I think we have quite a good situation. We are going to place the cable at a slight angle so that there is going to be less pressure being applied. So the wire is already at an angle. The insulation, the first insulation, the main insulation is going to be at a certain angle, so that when we are going to place it, it's going to be well aligned. I think that we did quite a good job. So right now let's go and screw. When screwing, pay close attention so that only the copper part is going to be placed in the screw pressure connector, because otherwise you're going to have less contact and sparks and obvious dangers like fire may not be entirely impossible. So pay close attention to this. Also, we notice that the cable is not overly long, so it should be able to survive quite well the mechanical stress. Okay, right now I think it's quite well secured. We are not going to over tighten, we are not going to under tighten. Of course, it's difficult to say what kind of force you should apply. Ultimately, as you're going to be able to improve your technique, you're going to have a good feel of it, and nothing else but experience is going to tell you when and how much you should be tightening. Another important aspect is that as soon as you have secured the cables, it should be able to withstand a bit of pulling. So if this one is going to be a good connection, it has to survive that. Even if there is a strain relief over here, it's still important to have very tight connections. All right, and right now let's untighten the strain relief. Okay, I think that untightening just one of the screws is enough, because we want to see how to better position it. Okay, as we are looking and paying quite close attention, we notice another issue. This part should be sleeved or placed over the cable. This small ring unfortunately has a major disadvantage in that it has to be placed over the cable, which may not be appropriate in this circumstance. We're going to see it immediately if it is so. And yes, unfortunately it is. I'm pretty sure that this part that has been uncovered may not be entirely smooth, or may not have a good surface, but still I don't think it could be able to slip past the external PVC sheeting. So I think that this again shows bad design, and you should be aware of this, because it's not appropriate to use with normal cables. So I'm not expecting it to fare particularly well without it. It may, however, be quite reasonable even that way. All right, we are trying to see how this part fits, and as far as I can tell, yes, we should be able to make this distance a bit higher, so that it's going to pass over the area where the screw has to be tightened. But let's see what happens. So we are going to pull slightly over here, so that more we are going to uncover more the internal wires, and I think we did quite a good job. As you can see, there is plenty of clearance near this area. And right now we are going to screw this part, because we don't have any other way of securing it, and see how well it fares. So yes, we notice that there was a bit of a slip over here. I assume that this may be due to not having the ideal placement of the cable over here. Now, I'm not entirely sure what should happen. As far as I can tell, the two halves are not similar, so it may be the situation that we would have to place it the other way around, and I think this may be the case here, because as you can see, there is an indentation over here. Actually, there is a bridge, an exposed part, and as you can see, that part, that protrusion, actually should not be on the cable, on the part where the cable is being tightened, because it would stick, and then you would probably force the cable in the position. So I think that this one should work. As you can see, yes, probably it's a good idea. Unfortunately, I still do not think it's a good design. Not only the retaining ring is just way too small for a typical cable, and I'm not entirely sure if using an even smaller cross-section cable would be great for 10 amps, but anyway, it doesn't matter, and particularly for this style of mounting. So yes, I think the design is still flawed, but it doesn't matter. We're not talking about a good brand plug. It's just your typical run-of-the-mill, no-name Chinese product. Let's see right now how well it fits. And as far as I can tell, it's not quite okay. Right now it's placed, it's secured. The way in which it wobbled a bit even before being completely tightened, I think it doesn't bode that well for durability, but anyway, this is just a way of having some doubts in this situation. Alright, so let's go and screw it, tighten it. Perhaps you should have been better. Okay, so of course not over tighten it, but tighten it well. And noticing how much the end connections are going to have a play. I have to say that there is a bit of a play over here, so I'm not expecting it to fare great over 10 years, but I think that for a couple of years it will be enough. Alright, and now we have to get back to our current challenge. So, I'm still not certain how we can... yes, I think over here it would be well advised to make a jump cut, because I do not have quite a good idea of how to unscrew it, and as far as I can tell, there is no hidden screw over here. So probably if there are retaining clips, they are very strong, which I doubt, or there is another way that this part should be unsecured. I can possibly expect to need a screwdriver, a straight screwdriver placed under one of these areas in order to lift it, because unscrewing this part, which to me seemed quite logical, was not, as it seemed, quite enough to separate the two sides. Alright, so yes, I think we will have to stop for the moment. Alright, mission successful. However, I still have to say that the design was not well thought out till the end. It was not bad, but it wasn't that great. You would have to place the screwdriver over here and then try to lift this side. And when you are going to lift it, actually you're going to notice that there are two more screws that you would have to take out in order to have proper space for connecting the wires. Most types of sockets that are designed that way are going to be easily released just by unscrewing the main tightening screw. Unfortunately, in this case, I have to say that lifting it was not quite obvious, because there were no indentations, and also the fact that you would have to apply quite a bit of force, and you would have to attempt not to break these sides that are a bit under stress. So yeah, anyway, so taking it further apart, we can notice the construction, and we are getting to a good part. This is a well-designed socket. It can clearly withstand 16 amps. I have no doubt about that. Good screws, good screwing plates, so the force is going to be applied quite well. So right now let's place it again inside and see how we can have a good connection. right now, yes, we have multiple ways of getting the cable inside. Probably it's better to pinch one of the two rubberized coatings. How you can do this? Probably with a screwdriver, but I'm going to show you again a very old technique. So using the sharpest tip of the scissor, you're going to place it in the middle of this protrusion, and then slowly, carefully, not attempting not to pinch your fingers, just to slowly make a hole. And of course, as soon as you made that hole, you can try to rotate the screwdriver so you reach more or less not particularly a circular hole, but one that is not entirely rugged. And right now, I will try not to make it too long and see if we have to. Yes, we have to continue. Then we can continue again with the scissor and make the indentation slightly larger. I think perhaps I overdid it, but it's not going to be by much. Okay, then make the cable pass this hole. As far as I can tell, well, you would have to pull back the cable a bit so that a reasonable seal is going to be possible in this situation. Of course, if the socket would actually be placed outside, I would advise against pinching and making the connection on the top side, because water ingress could reach the socket, and use the old tried and tested method of going with the cable slightly around the socket. If you would use a tube, and that tube would be tightly placed around the top side, there should be less chance of water ingress. However, I think that placing the cable on the lower side is the safest way if you don't mind the additional, let's say, aesthetical impact. The idea is the following: even if water can get inside the device, it would slowly drip outside near the cable without affecting the cable, without affecting the insulation. So direct water ingress would not happen, and the occasional humidity that may be inside the socket would not be able to easily affect something that is important. So I think that is a very good choice. And if the socket should be placed like that or not, yes, in general, I think that connections should be on the lower side. So if by accident the cable is going to be pulled, it would have very little chance of bridging another connection. It would just be loose out of the socket. I think that a cable that is unprotected inside the socket, it's loose. Actually, I think it's a real danger. So in that case, I would focus on placing the connections on the lower side. If you would like, yes, it's also possible to make a particular way of wrapping the wires around so that they make another loop, and in that case any sort of moisture that may be inside will not go directly on the lower side, would just stand around the unit, and then it would probably drip without having a direct path. And another major advantage would be that if the cable would be placed around like in a loop, it could probably withstand better some sort of accidental pulling. Of course, this is not important for cables that are placed in the conduits, but for ones that may not be, this I think still holds some importance. Alright, so let's strip the wires. I think that we should go for roughly 1 centimeter or something like that. I think it's correct. Again, go round and round, not applying too much force on the scissor. We're going to do this one as well, and then when we are going to be finished, we are just going to pull each and every insulation in a sequence. Okay, I think that it pinched. Fine. We are not going to insist one more over here. So just pull it using your nails. Okay, and it's loose. And the second one probably will do just as well, perhaps a bit better because yes, there may be slipping. Of course, if you have a lot of confidence in yourself, you could be using the scissor to force lift the insulation. However, you have to pay very close attention because if you're going to apply too much force, you may actually sever the internal conductor. And again, go and make some twists. I think around 3 or 4 twists is fine. And let's see how everything fits. So we are just going to put the connections for the left and the right one. We are not going to put earthing over here. Okay, let's unscrew it. As you can see, I can use a straight screwdriver with no problem. In some ways, it's good to know that the classic design is still working, but in most cases, it's not advisable because as you can see over here, it's very easy to slip from the screw. So you're actually going to wear the head of the screw quite quickly if you are doing this, and particularly it's not good. And you have to think about another aspect that obviously when you are doing such a thing, probably you're going to reduce the chance of having the screw survive as many installations as possible. Over here we are attempting to make the connection on this side so that there is as much as possible clearance between the two sides. This would not be entirely useful in this case, however, it's possible. Another situation where this would be useful would be if you actually intend to place another connection and place some sockets in line, so you could go and continue the link with no additional connectors. I still think that this is not a good approach because it's very easy for one of the connections to split, and the more sockets you're going to chain link this way, the more chances that something may go wrong at one of them and it's going to affect the others. So I don't think that this option would be good. Okay, I think we have tightened it quite well. Not over tightened, but not tightening it enough is just as bad. All right, so then pull it, and as mentioned, just ensure that you pull it a bit more than you should so that you can push it back through this insulation to ensure a good seal. All right, so let's see, I think this was the right way around. Okay. And slowly we are sliding it until we reach the main position. As you can see over here, we have no cable strain relief. This is typical for most sockets, so you don't have to think that there is something inherently wrong. This is one of the reasons why the cable probably would be looped inside, so that there would be some sort of strain release through the internal parts, so that pulling directly on the cable would not result in such an issue. However, in this case, since we are talking about a bench socket and I know how I'm going to handle it, this is not going to be a problem. You can see readily over here that there may be an issue with the current cable positioning, because it could touch the earthing connector and there may be a potential of breaching it if too much heat would be applied or resulted through connections. Of course, we're not going to have high currents, But pay in mind that this is not good. This is why the exposed part of the cable should be quite short, and then you would have to loop. Even if it's not required in this circumstance, I will show you how roughly it should be. So you would place the cable like that, make a loop, and then exit somewhere around here. And in this case, you would have a good way of making a strain relief on the cable, and it would have much less chance of affecting the integrity of it when it is accidentally pulled. This should not be the case, of course, for cables that are placed in conduits, because the whole network would be fixed. However, in cases where this may not be the situation, I think that it's good to know in advance that there are many shortcomings to this. As it stands over here, probably the best bet at avoiding any sort of issue would be to probably place the cables as low as possible. However, keep in mind another important aspect. Never use a screwdriver to directly apply pressure. Try to apply it at a certain angle, or use something else, not a screwdriver, any sort of device like a pencil or something like that, so that you will not pinch the insulation. If you pinch the insulation, actually you made the worst possible let's say issue. But as you can see, I'm placing it at a certain angle, so that is not going to pinch the insulation. Of course, I think that this is quite well for the current purpose. So we are going to place the upper side, and we are going to be prepared to tighten the screws. And as soon as we are going to tighten the screws, you will be able to get on the final stage and say that we have completed the socket wiring. You may have noticed that I haven't pulled on the cable, but you can readily believe it that I tightened very well those screws, so I'm not expecting them to fail anytime sooner. All right, let's move further. Perhaps with such an installation, it would have been better to place the wire on the internal on the parts that are closer to the center, because in that case the cable could probably have less chance of reaching this position if it's slightly let's say forced back. But I'm not entirely sure this would be the case, because a lower angle I think would mean that it has just as many chances of reaching this position. So we are going to tighten these screws, not over tighten them, because these are actually being screwed against poles that are actually made of plastic, so over tightening could make them break. And then place the upper side. So we are just going to respect the brand that probably is over here, and as you can see, you have to place quite a bit of force, and this is what I don't quite like about the design. Other than that, yes, it's a fine socket. And screw the final mounting one. Alright, don't over tighten it, perhaps, yes, check if you haven't over tightened. It's quite well. It's not perfect, as you can see. Probably I should have used the screwdriver from inside to make this part protrude even more, but for the current situation I think it's quite enough. It's a short cable, but it's perfect for these purposes, because as I'm using this socket is going to be placed in another multiple socket that stands between a desk or is going to be close by, so I don't mind the short cable, and in this case I made quite a custom solution that should have no problem in working. And right now the test shows on that we have to push quite forcefully this socket. I'm expecting it to be that strong because it was never used. Just in case it is stronger than it should be, you could place a screwdriver and slightly make the two halves a bit further apart, so that when this plug is going to be placed, it will have a better chance of sticking inside. But of course, don't overdo it, because anytime you're going to place another plug in here, you're actually going to make a poorer connection. As you can see, with a bit of force, but not too much, you're going to have a secure connection. So I think this just about wraps up the current video. I hope you enjoyed it, and if you like it, please subscribe to the channel and watch further videos. Thank you very much for watching, and have a pleasant day.